Hello class, today we are looking at transformations. So the essential question is, what are transformations? Learning intention. I am learning to identify the transformation, the line of symmetry, and the line of reflection. This will be our learning intention for the next several class periods. So we've got the warm-up. Given the mapping that will rotate a figure 90 degrees clockwise is your x and y are mapped onto y and the opposite of x. Rotate these points 90 degrees clockwise. So I need you to pause the video and see if you can do that on your own. I hope that you tried. So as we're looking at these mappings, first thing I do is to switch my x and y around. So -5, 3 becomes 3, -5. And then I have to change my x value that I started with to the opposite. So instead of -5, it is +5. Okay, if you weren't able to get it, pause the video now and see if you can do it now. Okay, let's look at 8, -8. Step 1, switch them around. -8, 8. Step 2, change your x value to its opposite. So after a 90-degree rotation clockwise, 8, -8 becomes -8, -8. Once again, if you still didn't get it, see if you can do the next one on your own. Step 1, turn them around. 101, -34. Step 2, change the x to its opposite. So instead of -34, it will now be +34. For the next one, 0, 0. We can't change it any, so it's still 0, 0. There is no opposite of 0. Okay, so that brings us into what we're now studying, rigid transformations. What does the word rigid mean? If you're sitting at a table, your table would be rigid. Your wall in your room would be rigid. Rigid means hard, unmoving. So a rigid transformation is a transformation that preserves the shape and the size of the figure. A transformation that preserves the shape and size of a figure. Okay, so the rotations we were doing yesterday are rigid transformations. If you do a slide, if you pick it up and move it from here to here or wherever, you're not changing the size. That would be a rigid transformation. If you do a reflection, you're not changing the size. That would be a rigid transformation. Your pre-image, that's what you start with, will be congruent to the image, which is what happens after your transformation. Okay, so we'll talk about a rotation. We talked about it yesterday, and we did some. A rigid transformation that rotates the figure around the point called the center of rotation. So a rigid transformation that rotates a figure around a point that is called the center of rotation is what we call a rotation. So there are three things you need to know. If you're going to do a rotation, there are three things you have to know to be able to do it. First of all, you need to know where the center of rotation is. Because if you don't know what you're rotating around, how do you know when you got there? Number two, how many degrees are you rotating? The number of degrees of rotation. So we've got to know the center, we've got to know how many degrees we're moving it, and you also have to know the direction of the rotation. You have to know, are you going clockwise or are you going counterclockwise? Okay, so we had these two figures yesterday in our notes, and we marked them then. If you still need to mark them, this would be clockwise, counterclockwise. Think of the face on an analog clock. Which way does that red hand go? Okay, so that brings us up to the next rigid transformation we're going to talk about, which is a reflection. A reflection is a rigid transformation that maps a point to its mirror image over a line of reflection. Okay, I'm going to have to move that over just a little bit. Okay, so if you're looking at it, what do you need to know? You're going to take this and you're going to reflect it over this line. Well, you've got to know where that line of reflection is, because you're going to count. If you're looking at point C, it is 1, 2, 3 from the line of reflection. 1, 2, 3 again. So it's going to be the same distance. The mirror image points are the same distance from the line of reflection, just on opposite sides of the line of reflection. So you have to know where the line of reflection is. Okay, so we've gone through rigid transformations, rotations, and reflections. Now we're coming to a translation. When I think about a translation, I think about picking something up and just moving it. So if I translate this pen, I could translate it to the right, and I could translate it up. All I'm doing is picking it up and moving it. So if I'm looking at this translation that takes A, B, C, D, onto EFGH, then I know I'm going left 7 and down 9. Left 7 and down 9. So when we go right or left, is that your X or your Y value? So the way I change my points, XY is mapped onto. Left or right is my X value. I'm going left, that means I am subtracting 7. I'm going down, that's my Y value. That means I am subtracting 9. That is my mapping. So how do you apply this mapping? Well, let's look at the point A. It's 1, 3. 1, 3 would be mapped onto 1 minus 7, 3 minus 9. So that new point would be -6, -6. Okay, -6 is right here. So you figure out how it moves, and then you do that math to your original point to get your mapped point. So what do you need to know? Well, first of all, you've got to know which way it's moving and how much. So you need to know the units and direction the figure is moving, both horizontally and vertically. Actually, you're going to want to know the vertical first because the vertical is your X, the horizontal is your Y. Okay, we talked about pre-image and image yesterday. I don't know that we defined them, but we did talk about them. The original figure before before the transformation is the pre-image. In other words, what you start with. Okay, so your pre-image is what you're going to start with. Your image is the figure after the transformation. So, pre-image is where you begin, image is where you end up at. Basic rigid motions. There's 3 of them, and you can also do a combination of the 3. So, translations, rotations, reflection, or a combination of these 3. Translation is picking it up and moving it. Rotations I always think about a circle. You're going around in a circle. You're picking it up and moving it on that circle. Reflections. That's where you flip it over a line or a combination of the three. Okay, so we've got our image down here, and we're going to translate it. So I'm going to call this A, B, and C. I've got to know the points of A, the point of B, and the point of C. So A is -1, I think it's -1, -9, but I got to count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Actually, it's -10. So it's -1, -10. B is -1, 2, 3, 4, 5, 6, 7, -10. And C is -1, 2, 3, 4, -1. Okay, as I'm looking at this, I'm going to take whatever x value it is, and I'm going to move it 3 units to the left. When I subtract, it goes left. So that means either left if it's for the x, or down if it's for the y. If you're adding, it means right if it's for the x, or up if it's for the y. So let's look and see. We're going to go 3 units to the left, 5 units up. Okay, so for my first point, I'm going to do the counting and show you where it's at, and then we will check and make sure that's the right one. So I'm going 3 units to the left. 1, 2, 3. 5 units up. 1, 2, 3, 4, 5. So this is my A prime. So at my mapping, -1, -10 is mapped onto. Okay, what do I do to my x? I subtract 3. -1 minus 3. What do I do to my y? I add 5. -10 plus 5. And that gives me the point -4, -5. And is that where I'm at? -1, 2, 3, 4. And then I go down 1, 2, 3, 4, 5. So as you can see, you can either count as you're doing it, or you can apply the rule and find the next one that way. So for B, okay, -7, -10 is mapped onto. Okay, so let's get started. -7 minus 3 more, and -10 plus 5. That gives me the point -10, -5. So -10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. -5, 1, 2, 3, 4, 5, and it is right here. This will be B prime. Prime means it's your second, that you've done everything. Okay, and then finally for C, I'm taking the point -4, -1, I'm mapping it onto -4 minus 3, -1 plus 5, and that gives me the point -7, -4. And I'll move that on down. So that gives me the point. -4 minus 3 is -7. -1 plus 5 is 4. So this is -1, 2, 3, 4, 5, 6, 7, and then I go up 1, 2, 3, 4. So this one would be C prime. Prime means that you've moved it. You've taken the original and you have moved it. Okay, the last thing to do is to connect our dots. We need to create that new triangle. So taking a straight edge of some type, whatever you've got handy. I think I'm going to connect my dots in red so you can see them better. Okay, remember when I told you that geometry has a lot of algebra? Well, this algebra here is pretty easy to do because it's adding or subtracting, but it's still algebra. So, summary. These are the types of transformations. Okay, I'm going to have to move that down. I didn't leave myself enough room because I wrote too big. Hence the erasable pens all the time. Rigid simply means hard. The types of rigid transformations, make sure you understand them because we will be working with them.